the side here is very rigid and robust. You know? Even you put your hands in, it will not scratch your hand. Very tough. So they designed it like this. So all refrigerant will come just like straight way, straight. Unlike the normal copper coil tube, it will go like this. Before it drops like a liquid. Here no, one passes through this superheat, at the bottom it's liquid. It goes to the other side, liquid. But straight line. So it's not like it will go like that, no. It's a straight velocity of refrigerant.
Actually, the copper aluminum, compared to copper aluminum, the efficiency is higher by 5% almost.
It can be cleaned by water, right?
It can be cleaned by water as well as with blower, both.
Okay.
You mean
The cleaning.
cleaning is, you just need a very small amount, even a hose, garden hose, it will clean. Unlike copper,
I thought there is
aluminum.
needed something to be.
No,
water we have.
Water, yes.
I thought there's something else.
No, nothing. And also the thickness is almost 1 inch only, 25.4 meter, 1 inch only. The thickness. So it's
By the way, what time we will go to that side? Because there will be another meeting. So once we left, they will.
2:30. 2:30 we will go. 2:30. Yeah. 2:30 we will go there. 3:30 to 4 o'clock. From there we can. 1.5 hours, right?
What time?
Maybe 3 o'clock we
Okay.
can go. 2:30.
2:30 because we go there half an hour to go up and all that.
Let me continue.
Yes,
So
yes.
we can cover more. Well, you saw this in your in your area. Okay, this is the back side of that. That your bottom here is a cooling area, and your condensing area is on the other side. This is how the system works. Like your system 1 is here, and system 2. So it will be 6, 4, 6. So it will differ depending on the tons of the machine, tons of refrigeration. That's your cooling coil. This is the one which cools down the glycol solution cooling
For the
system.
VSD.
For the IGBT inside the panel. In the VSD, there's a heat sink. The heat sink inside is hollow. What it cools? It cools the components inside and cools the panel. Now there's a temperature, 218 degrees Fahrenheit maximum for the IGBT, high base plate temperature. And for the panel inside, should be not more than 158 degrees Fahrenheit. If this goes on that maximum temperature, go to the history book and then trace why. One reason why it goes, maybe the glycol pump is not running due to what? Maybe the relay coil is not working. Or there's a leak in the pipe on the glycol. No glycol solution to cool down the VSD. This one. Or the dedicated fan is not running. Gentlemen, the glycol pump will run independently. The pump at the bottom to cycle the glycol and cool, and this will run. Even the chiller compressor is not running. Why? To maintain the temperature in the panel inside and the VSD. So don't get surprised if this fan is running while the other compressor or the compressor is not running, because it is independent. It needs to control the temperature, not to reach 158 in the panel, not to reach 218 in the VSD, IGBT. We will show you where is that VSD thing. You don't have this one. This is inside the panel, one coil unit. Inside of this coil is glycol solution. Like in radiator, you put what is radiator? Coolant. It's a coolant. Instead of water, it's a propylene glycol. The reason for propylene glycol is that it produces refrigerated air dryer and it will not reach dew point.
Okay.
What is dew point? Condensation. We don't want condensation inside, because condensation will drop here.
Electrical.
So
Electrical
there's
fan.
an electronic boards here. So we don't want to miss this fan blows towards here directly. and cools the whole panel when it is closed. At IP5455, this panel should be totally sealed. No water will enter nor dust. IP55 or 54. Okay? So that is one of the cooling system for the panel, and this is a heat sink. Yeah. That is hollow. There's a pipe here entering, pipe leaving to the glycol cooling system here. There's a pump at the bottom of the chiller that will circulate to absorb the heat coming from this VSD controller. This is a semiconductor device. This is a semiconductor device also. The IGBT, this is the semiconductor device. This is your main VSD power, supply to the compressor. It will control, it will provide frequency from this output to compressor 1, compressor 2. Okay. There are 3 wires here. Line 1, 2, 3, line 1, 2, 3. Compressor 1, compressor 2. Directly, there's no conductor here in between. So the one who's triggering power to the stator winding is the IGBT here. The IGBT is very specialized inverter. Okay, it's a very special inverter which provides frequency from 0 Hz to 100 Hz. Now what is the loading? It will load 0.2 Hz per second. But the speed is 10 Hz per second. Okay? So the speed is like a car. The speed 100 kilometers per hour. Here, the microprocessor board will control that speed through frequency. So it will start from 0 Hz, 0.1, 0.2, 0.3, and so forth. So it will go up to 200 Hz. So the steps on that will be around 2,000 to 20,000 steps. So from 0 Hz, 2,000 steps. It is by 0.1. Okay, loading is 0.2 Hz per second. Can you imagine the loading precision?
Like camel.
Like what?
Like a camel.
Camel? I don't know, I couldn't.
Like
Camel,
very slow,
camel.
very slow.
Yeah,
Loading is very slow.
yeah, the loading is very, very slow. Very, very precise. Steps. Means to say almost like stepless control. That's why we call it stepless control. So this is how it works here. Your glycol pump is at the bottom of the chiller. It provides you the glycol solution there. Every 5 years, you have to replace the solution. Our guys will replace it, I see. Yeah? So you don't have to worry about replacement. It's recorded here. Ensuring that glycol is there. This is your stepper motor valve, which we told you, the electronic expansion valve, the feed valve. Okay? There are 2 here. One is economizer. Okay? We'll tell you about. This will look like your electronic expansion valve or feed valve. There's a side glass here or moisture indicator also. If it is green, no moisture. If it turns yellow, you have an issue. Moisture enters the system. What we have to do, we need to remove the refrigerant. Because there's water already in the system.
This is very important also.
And then
We have to remove refrigerant.
Sorry?
Yes.
We have to remove refrigerant.
When it turns yellow, your liquid refrigerant or refrigerant is already has moisture. And to remove it, you circulate it, but before it recirculates or before it goes to the core dryer, maybe it already will flow to it flows to the compressor. So we need to refurbish the refrigerant. We have to reprocess it, recycle it, and then reclaim, recycle. If you can reprocess, that's fine. But this is only one part of monitoring the integrity of the refrigerant. Huh? Moisture indicator and side glass. This is how it works. Okay. This wire. There are actually in this wire there are 2 coils. 1 coil for opening, 4 coil closing. This one is connected to the flush tank controller. The black one, when you open the panel, that's why there are 4 terminals there. Okay? So if there are two compressors, there will be like feed valve here, economizer, and another feed valve economizer for compressor and N2. We will show you that. But this is a relief valve here. We told you here, compressor frequency plus economizer. Remember the diagram? The EEV will open at this frequency. Okay? This is what we told you.
Yeah.
Then below it will stop. It's a PS diagram which we told you about this and this, right?
Yes.
Which is related to that. So, transparent, look at the compressor. Terminal 1, 2, 3, you have sensors here. For what? For stator winding. You have S1, S2, S3, common. Okay? So this monitors the temperature of the winding. If the temperature reaches 250, we have an issue also. Okay? But before it reaches there, you need to understand. You need to go behind what happens to the stator winding. You might need to measure it. Our guys will do that, I think, because of that. So you don't have to worry about it.
It shows in the display, right?
Sorry?
It shows alarm in the display itself.
It will,
Display.
on the display, that it will show some like it's reaching this much. But before it reaches there, it will unload the system before it goes to a high discharge or high temperature or high current. Because we don't want motor to heat up. VSD monitors the temperature, pressure, saturation, superheat, subcooling, everything. Then it analyzes, hey, there's something wrong. I need to unload while maintaining the temperature.
So there is any reason why I will not replace the oil?
Coil?
Oil, compressor oil.
Compressor oil.
Any reason?
It's not changeable. I will not replace the oil.
When the machine is operating, you did not open anything, nothing. Operating parameters at fully loaded are normal. The quality of the oil when you remove little of oil is still, because this chiller will run up to 99,999 straight without changing oil even. Unless the water becomes like coffee, then you need to change the oil. Mean the number of hours of the machine doesn't require you to change the oil. Unlike receipt or other conventional chillers, there's a 5,000 hours change the oil.
It shows in the operation and maintenance.
Yes, it's
How
there.
many hours working, and then we have to change.
No, for a year, no, for a year in the maintenance, you have just to collect.
Yes.
Collect oil, check the color, or if you want, test the acidity. If you want chemical analysis, send it to my colleague here for analysis. But it's a very long process because it will show you all particles, parts per million, TDS, and many other chemical properties if you wanted to. But for acidity, it's easy.
From time to time, you can check it and send for test.
But not
Because
much
nothing
length.
is
Every
permanent.
year. Every year only to collect the oil. That's it.
Somebody run the AC. Somebody make the thermostat.
Going back here, because look, gentlemen, just to give you an idea what it looks like here.
Sajid, check this thermostat.
Okay, so you have direct connection from the IGBT here.
Can you go to the
Shut
microprocessor?
Yeah, I will. Okay, anything you would like to ask? So that's basically the compressor construction.
Okay.
Okay, that's basically it will work like that. Your filter is there, there's a service valve here, and this is your economizer port, your distance line. Your crankcase heater is somewhere between on the base line, to ensure that when compressor is off, heater is on. When compressor is on, heater is off. So similar to other. And temperature sensor is there, and your HPCO is there. We have an old version of that. If I go to that, let me go to the other. This is the front side of that machine. Sorry. That's your. This is the inductor we're telling you about, the inductor system. Remember the inductor to collect that?
We remember, but we not see before.
That's the connection, physically. You go to the job site, you'll find this. Filter core and your inductor system there. And internally, it is constructed like this. So where is your high pressure? It comes here, goes there, absorb the refrigerant from here. Okay? And then goes back to the compressor suction line. This is how it works. This is from the oil refrigerant mixture. That's it. If you allow me, let's go more further on the main topic which we.
Can we have that file, PowerPoint?
Sorry?
Can we have that PDFs?
I'll try to see if I can send you the PDF. You're telling me something?
Microprocessor.
Microprocessor.
Okay. Because
Yes, yes,
they are not much clear
Yeah, yeah.
about
Okay, just put it down. And your condenser fan is still with contactors, by the way. That's the only one with contactors. So your contactor will hold either 2 or 3 motors. Because the motor is only 1.5 amperes or 1 horsepower. That's it, very small. This is a VSD logic board, which is one of the which controls frequency also, which provides the frequency of up to 200 Hz. This is a micro computer board. It means to say this is the master decision maker for, or the motherboard. So all of the data is inputted here, like the analog signal here. What are the analog signals? These are the pressure transducers, temperature sensors, suction, oil, discharge, okay, HPCO, and many other things. These are the input. System 1, System 2. These are other things which we can connect somewhat like a mobile printer here. This is a communication for on-off BMS. But if you need a BMS system, you need an E-link, which BMS, which you would like in your computer to collect all the data. So you need an E-link there to what? To translate our protocol to your protocol, whatever you will use. If it's ours, then they can.
Now
gave
it's
a-
open protocol.
It's
Yes.
an open protocol for
It
everyone.
is
else.
and
Like
we have
M2
provided in
long
that
in Backnet.
E-link.
Can we,
But-
I mean, during the time for BMS to start commissioning,
Yeah,
can you come with us?
yeah, no problem. Actually, we provided. I'm not sure because we provided to Gulf Group for the. They asked for the points. Which are the points they want.
Okay,
And
and that's
we-
how I visit you.
Okay.
Okay. Anyhow, your VSD, which is connected to the logic board, there's a wire here. There's an LED here, which keeps on blinking, transmit and receive. This is saying that it is communicating with the VSD logic board to the controller board, ensuring all automation is proper. So that control. So this is the main, like a computer laptop. It's the motherboard of all. It just controls data, analyzes data. It's a central processing unit also. So it automates everything here. That's your basic logic board. That is the main control board, which is communicating to this as well. Another board, which is we call it semiconductor board or the SCR trigger board. It has a safety features which provide monitoring of three-phase. If one of the phase line input is not there, the machine will shut down. If it is running, will give you a phone, single phase volt loss voltage. If the machine is on standby and then would like to start, it will not start. It will give you single phase loss phase voltage. Even for a half cycle of a 60 cycle. Because remember, what is 60 cycle per second? 60 hertz. 1 of that 60 hertz, even that, if it's lost, this monitors that. So machine will not run because you have one phase out. You don't want single phase in the motor, right?
Yes.
What happened? It will burn the motor. So it's a compressor also, will burn our compressor. So it's a safety feature here. These three plugs here with 2 wires are connected to the semiconductor device. One wire there is like a controller from where? From you. You control one of these wires here. Where you will control. When you press the button, system switch. At the bottom of the panel, there's a button there, system switch. And then you select the display on, scroll on. You trigger the check mark, press that button. You actually open one of the wire here. This is how it is. This SCR trigger board will immediately charge the bank capacitors like a mobile charger. It's like a mobile charger. When you press that button, charge the bank capacitor on the VSD. And within 90 seconds or less, the bank capacitor is fully charged of volt DC. Now your machine is 380 volts, correct? If it is 380 volts, I expect your DC at the VSD, DC would be 537. How I get that? Do I just guess it? No, sir. From electrical point of view, you multiply square root of 2 to 380. What is 380? Remember, why square root of 2? Because you have only 2 output. Your 3 is line 1, line 2, line 3, correct? But your output is DC. You have 2 output only, 2 wires. So the output of that, multiplied by square root of 2, your input is 380. So the output is DC. So 380 multiplied by square root of 2, 1.414, it will be 537 volt DC. Now, what happens if the DC bus voltage in your display is less than the way I would like it to be, which should be 537? Check out your input. Maybe perhaps, most probably your input is fluctuating. It's dropping the input voltage. If it is not 380, maybe it's 360, 355, or 350, or 342. Your output DC will be less. We need 380 on line 1, 2, 3, please. Otherwise, you need to ask, or you need to adjust your substation or your control substation to provide this machine 380, line 1, 2, 3. Otherwise, your full generated DC in your bus will not be there. And also, there's a security here. If it's less than 500 volt DC, it will not run compressor. Why? Because definitely it will go high current. And you will just have a shutdown high current. We need to determine why the DC is low, lower than 500 volt. The full voltage is 537 according to the law of electrical code. Okay? So input 380, DC, the 380 is AC, remember? From your line, input line to the machine, correct? That is coming from your from your power plant,
Yeah.
380 from your MCCB. It will go to the fuse of our of our machine. After the fuse, will go to the semiconductor device, and then it will charge the bank capacitor. The full voltage there within 90 seconds. When you push the system switch on, it should be 537 volt DC full. If it is less than, your input is dropping down.
We have to
You
check
have to
this
find
one
out
side.
why.
We have to check this one on the side when we go there.
Yes, no. So from that we can also determine why it's fluctuating. Maybe you need to adjust your substation or MCCB. Maybe the length of wire is too much. So you have a
provide
trap.
this surface for checking the.
Megger and all this.
Okay. This is your power. This is like your VSD power assembly. We used to say that where to find the DC. When this is open, you need a DC meter, voltmeter. Start at 1000 volt DC. PPE. Goggles, electrical gloves. Put your probe red, black. You put it here. That's your positive, negative. Your meter should indicate 537 volt DC. Your input to the power here is 380. Got it?
Yes.
This is line 1, 2, 3. 380 volts, 1 to 2, 380 volts, 2 to 3, 1 to 3, 380 volts. 1 volts, 2 volts difference will not harm the machine. But if line to line, there's an acceptable level of unbalanced voltage. How much is that? Electrical code says should not be more than 2% between line to line. So we monitor it in the beginning and even during.
The mechanical, the key available, most mechanical room, everything.
Okay, here,
Was who?
that's your semiconductor
That is open.
to provide DC to the machine, and then this will invert the signal to a proportional voltage, which is alternative signal, which is in frequency. DC bus on and off, which we call it pulse width modulation signal. Now, can you use your ordinary meter to measure the voltage here and current? Your ordinary meter will provide you insignificant measurement. Why? Because your meter is not compliant or not applicable to 200 hertz. If you have another meter which will monitor more than 200 hertz, and you have a voltmeter which will accept that, then yes. That's why you might notice there's a screen here, correct? Plastic screen.
Yeah.
The opening is here only, right? Because that's the only one which you're going to measure. Here, no need. You are not somewhat like insignificant for that. Even for our service people, we don't do that. Only here is very important here. Your voltages, line 1 to 20 and so forth. These are one part which monitor half of the DC here and half of the DC plus and half minus. These resistors here. They're like breathers. If you notice on the panel, there's a warning sign. Warning. After shutdown, wait 15 minutes before you open. Right? If you read the sign, operations. The reason why it needed 15 minutes to bleed off from these two to drain the power on this bank capacitors. Okay? After 15 minutes, the power here should be 0 volt DC. Where it goes, when it is shut off, no power. These breather resistors here, they are like the drain, like water. You remove water from your tank. Where it will go? It will go at the bottom. The same way here. When you shut down the power from your MCCB or disconnect switch, no power at all. Wait 15 minutes. The power should be drained here in the CC source. So that should be about. Then that's the time you can somehow do some maintenance there, cleaning.
So we have to wait 15 minutes
15 minutes.
until the drain.
For me 50. But after
For
15
safe.
minutes, still put your meter
Hmm.
here. Because you'll never know, maybe your disconnect switch has a mechanical failure. Maybe one is still connected when you shut it down.
Yeah.
One of the mechanical disconnect, at times they fail in one of the lines. And somehow, maybe one of this is alive, and then you suddenly touch it without thinking it. So it's a safety reason. You have to wait 15 minutes, then put your meter AC here. Check, no power at all, and then DC, no power at all. Then that's the time you can handle it. But with care, huh? Make sure that everything will be safe. Look, the controller, first priority here is safety. The secondary is your other team. Third is the machine. Machine we can replace, but not humans. Okay? That's the main point here. So this is the bank. The bank capacitor is here. The full power is in this TSP. That is on top. That's your IGBT board, which will provide gating to the IGBT there. The inverter, signaling to provide frequency to the compressor. That's the side view of that. So it provides you a side view there. This is what we said, huh? It switches DC bus on and off, creating a variable voltage and variable frequency to the compressor. Here's the output there. That output is this, which simulates that sine wave here. This compressor, gentlemen, our free compressor is not DC compressor. It is an AC compressor. So don't say that it's electronic control. Or how come it's AC? How come it's still AC? It's AC. But it is providing you that signal which is acceptable by the compressor because it just accepts energy. The energy is by frequency, speed of the motor, and energy which the compressor doesn't recognize what it is at all. All it receives is energy. Low energy, high energy, medium energy. That's it.